Okay, so I think everyone needs a little refresher on angle relationships. This was from chapter 1. It was the last thing we learned in chapter 1, so you didn't have a whole lot of time to absorb it before we took the test. Some reminders: parallel lines create angles that are congruent. You've got the checkpoint material is in the back. If you have a textbook at home, it's on page 717. If you're looking at the ebook, it's in the reference section and it says checkpoints, and we're looking at checkpoint number 3. All the names for the types of angles are on page 717. Angles in a triangle add up to 180. The exterior angle equals the remote interior angles. Vertical angles, linear pair, isosceles triangle. So all the things that you're supposed to know about angles are on page 717, and then you've got a couple of examples to help you review. So I'm going to go through 1 through 20, and I may split this up into 2 videos just so it doesn't get too long. Okay, so looking at number 1, I have an isosceles triangle. The base angles in an isosceles triangle are congruent, so I know that 3x plus 2 equals 4x minus 2. X is on both sides. Let's get rid of the smaller one. So x equals 4. Okay, number 2, I have parallel lines. These two angles will not be equal to each other if I trace this angle and slide it down the transversal and look at it, look at the angle underneath it, those two angles add up to 180. That's a linear pair. So y minus 48 plus 3y equals 180. These two are going to add up to 180. Those are called same side interior angles. I didn't write what these were called. These are base angles in an isosceles triangle. Okay, so I know these are going to add up to 180. I have like terms. Y plus 3y is 4y. I'm going to add 48 to both sides. And then divide by 4. There we go. Okay, number 3, we have, let's see, I'll just do this. Okay, number 3, we have an exterior angle, and that exterior angle is equal to the sum of these two remote interior angles. So 110 is equal to 34 plus z. So I'm going to subtract 34 from each side. 110 minus 30 would be 80, minus 4 would be 76. Okay, for number 4, we have a linear pair, or you could call it a straight angle because it's on a straight line. So remember, a full circle is 360. An entire circle would be 360. Half of that would be 180. So 3x minus 1 plus 52 equals 180. We've got like terms, negative 1, positive 52. subtract 51 from each side, divide by 3, so x is 41. Okay, for number 5, we have parallel lines. So I know that these 4 angles are going to be equal to these 4 angles. If these 2 lines are parallel, cut by a transversal, the angles must match up. This angle and this angle are alternate interior angles, so I know they're equal. So I know 3x plus 14 equals 4x plus 9. X is on both sides. Get rid of the smaller one by subtracting it from each side. Take away 9 from both sides, so x equals 5. Number 6, we have a triangle, and I know all the angles in a triangle add up to 180. So I'm using triangle sum. So I know 5x plus 3 plus 2x plus 17 plus 90 equals 180. Combine like terms. 5x and 2x is 7x. 3 plus 17 is 20, plus 90 would be 110. Subtract 110 from both sides. Divide by 7. Okay. Paper. Number 7, we have another exterior angle. So I know it's going to be equal to the sum of these 2 remote interior angles. And I've got an isosceles triangle. So I know the base angles. These are, by the way, in an isosceles triangle, the 2 sides that are equal are called legs. The side that is not equal to another side is called the base. So these are the base angles, the angles that include the base. So I know that x plus, if this is x, this is x. X plus x is going to be equal to 110. X plus x is 2x. Divide by 2, so x equals 55. Number 8, we have 2 angles that are complementary. So I know they're going to add up to 90 degrees. So 3x plus 3 plus x plus 7 equals 90. Let's combine like terms. 3x and x is 4x. 3 and 7 is 10. Subtract 10 from both sides. Divide by 4. So x is 20. Okay, another case of parallel lines in number 9. Cut by a transversal, so we know these 4 angles are going to match up with these 4 angles. Because I see an x and a y, I'm thinking to myself, we need to be strategic about this. Oh, we have to solve for both of them, so we're going to have to use each one. Okay, so there's a linear pair right here. So I know 63 plus 3y minus 12 equals 180. I know these are going to add up to 180. Full circle 360, half a circle is 180. Combine like terms. Let's see, that would be subtract 51 from both sides. Divide both sides by 3. 43. Okay, so y equals 43, and then you could set this up different ways. I'm just going to look at these 2 angles right here. I know that these two angles are going to add up to 180, because if I were to trace this and slide it down, it would match this angle right here. So I know that these two together are going to add up to 180. You could also plug in 43 for y and figure out what this angle is right here, and these two angles are going to be equal to each other. So there's more than one way to do this. I'm going to say for these, by the way, these are called same side interior angles. So 5x plus 2 plus 63 equals 180. Combine like terms. Subtract 65 and divide by 5. Okay, number 10, we have a triangle. All the angles in a triangle add up to 180. So we're using triangle sum. So m plus 8 plus 2m minus 3 plus m plus 6 equals 180. Let's combine like terms. Okay, so combine like terms. That's going to be 4m. Let's see, positive 8, positive 6 is 14 minus 3 is 11. Subtract 11 from both sides. Divide by 4. Whoops. Divide by 4, so m equals, oh, this one's going to be a decimal. Make sure I did this right. Oh, yeah, it is 169. Oops. Divided by 4 is 42.25. Okay, I'm going to stop there and do a new video for 11 through